Sample problem 1. A vertical angle of plus 13 degrees 45 minutes is read to a target 1.23 meters above point B. The measured inclined distance, S, is 823.29 meters. And the elevation of point A is 123.65 meters above datum. If the height of instrument at A is 1.35 meters, determine the difference in elevation between A and B, and the elevation of B. Analyze the problem. The first line reads: a vertical angle of plus 13 degrees 45 minutes is read to a target 1.23 meters above point B. A positive vertical angle indicates a telescope with a line of sight tilted upwards. So that a positive vertical angle of 13 degrees 45 minutes means that the line of sight is above the horizontal line passing through the telescope of the instrument. And a target 1.23 meters above point B means that the rod reading RR is 1.23 meters. Next line. The measured inclined distance, S, is 823.29 meters. And the elevation of point A is 123.65 meters above datum. The measured inclined distance S is the line of sight, starting from the telescope up to the rod. This distance S is inclined upwards because of the positive sign before the vertical angle. Also, the elevation of A is positive, which means that point A is above the datum. Lastly, if the height of instrument at A is 1.35 meters, determine the difference in elevation between A and B, and the elevation of B. The height of the instrument 1.35 meters is the height of the telescope from point A. We are then asked to compute for the difference in elevation between points A and B. That is, dE sub AB. And the elevation of point B, which is the vertical distance from the datum up to the ground surface at point B. Next, how to draw the figure. Step 1. Place point A on the left side, and point B on the right side. Step 2. At point A, draw the instrument. The height of the telescope is 1.35 meters above the ground. Starting at point A, indicate the elevation of A as 123.65 meters, which is the vertical distance of point A from the datum. Step 3. Draw the line of sight. This line is tilted upwards because of the plus sign before the vertical angle. Start from the telescope of the instrument and terminate at the rod. This line is the inclined distance S, equal to 823.29 meters. Step 4. At point B, draw a rod. From point B to the line of sight, draw rod reading RR. Rod reading starts from the ground surface at point B, up to the line of sight intersecting the rod. The rod reading RR on the rod held at point B is 1.23 meters. Step 5. Starting at point B. Indicate the elevation of B which is unknown. And this is the vertical distance of point B from the datum. Step 6. Draw level lines passing through points A and B. The vertical distance between these two lines is the difference in elevation between A and B. That is, dE sub AB, which is also unknown. Solution. Step 1. To determine dE sub AB. First determine V. Refer to the triangle drawn at the right side. Sine alpha is equal to V divided by S. Then, sine 13 degrees 45 minutes is equal to V divided by 823.29. Cross multiplying, we have V equal to 823.29 multiplied by sine 13 degrees 45 minutes is 195.68 meters. Step 2. Start at the lower point A. Move upwards until we reach point B. To enable us determine dE sub AB. From point A to the telescope, movement is upwards. That is why HI has a positive sign. To start with, we have dE sub AB equal to positive HI. At the telescope, there is a level line. All points on this level line have the same elevation. We now move from the left side of the drawing to the right side of the drawing. At the level line, the vertical distance D is connected. Movement from level line to the other end of V is upwards. So now, we have dE sub AB equal to positive HI plus V. Then, at the other end of the vertical distance V, is connected another distance RR. Movement from this end to point B is downwards. And finally, we have dE sub AB equal to plus HI plus V minus RR. Substituting the values of HI, V and RR to our equation gives dE sub AB equal to plus 1.35 plus 195.68 minus 1.32, which gives us a value of positive 195.80 meters. A positive dE indicates that point B is higher than point A. Step 3. Now, to determine the elevation of A, look at the figure. The vertical distance elevation A plus the difference in elevation between A and B dE sub AB is equal to the vertical distance elevation B. So that elevation B is equal to elevation A plus dE sub AB. Substituting the values. We have elevation B equal to 123.65 plus 195.80 equal to 319.45 meters.